reason, TikTok thinks I don't have internet on this system. I don't know what's going on. If restream. Wait, maybe I can just do it through here. What do you put this under? No. Yeah, whatever. Like we are only doing a Twitch, YouTube, and Twitter stream today. Updating live studio. Okay. Let's see options. Come on. I don't have the stream going yet. Like, come on. YouTube. It's scheduled for 9:30 p.m. Oh. Oh, wait, it says I'm live. Okay. So, hey, what? Um, yeah, I don't know what's going on TikTok. It's freaking like all over the place. Maybe I can see chat from, I don't know. I'll leave this open. We'll see. Although it's probably going to get upset at me because it's trying to encode too many things at once. Well, I guess I just won't answer TikTok if anybody says anything. So. Oh, well. My hearing in Discord. Oh, wait. Wait. Where is this? Oh, it's live now. Okay. Is NVIDIA live? Oh, I saw a flicker. It started. Oh, can I hear anything? There you go. Oh, I should probably... a little loud, but you turn it down a little bit. I thought it was supposed to be... I don't know why they had a timer that ended at like whatchamacallit. Hype train in Kevin. Do I bother messaging all these people again? Probably not. L. Be here for a second. I guess I could go do a map real quick. No, not the guild. No. My hideout. Wait, now waypoint. Oh, that's perfect, actually. There's a tower right there. Yeah, whatever. Fine, we'll do it. I don't care. We got a few minutes. Wait for Zeke to finish his match, too. Hi, kitty. Yeah? Up here to say hi? That was fast. Why are there people up here? Well, that was quick. Packing stuff on my desk. Packing stuff. All right, we got to be close, right? 9:24. 5 more minutes. Kitty. Hmm? Came to hang out, apparently. Up and just... Got me? How much time we got? 5 more minutes. Come on! He's like, hey, you moved too much. Oh. And knocked. Let's see if he sees it or not. Boom, 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 boom. Come on. NVIDIA keynote begins. Could be the reveal when it occurs. Come on. It's coming.
DPS gotta turn around for that.
I don't know what Zeke said.
No.
Oh, try that again.
Logan.
I don't know if that's... Come on, one more minute. Oh, I tried. God, that was loud. I tried them a few times. Nobody's home yet. I think I broke it. I said I tried knocking it a few times, but it didn't work. Yeah. I mentioned it. Whatever. Come on, it's 9:30. I want to see it now. But make sure the YouTube stream's on it. Nope. They have a higher quality over here. Let me see. They have 1440. Do they have 14? Nope. NVIDIA does not have 1440 on Twitch. So, switch this over to YouTube. Oops. Let me move this window over here, actually, so I can just still talk in chat. What was that? This is George Seb. Welcome back, George. Why the music just get all weird? Oh, the lights are working. Forgot I had the camera on. Welcome back, George. For 20 months, man. Thank you, thank you, thank you. Supposed to start minutes ago. Time is money, friend. Somebody just rated NVIDIA with 900 viewers. Why? Why wouldn't you just co-stream it? Sorry, I was getting ready for GTA 6. Let me in. What is this? 9:30. Come on. Come on. Like I'm watching both to see if it's on either one. Well, I wasn't anticipating this to be on time. I wasn't expecting to not have it start on time. But that's fine. We'll sit here together. Oh, shared chat started. Somebody did it. Bam. Oh, wow. That was perfect timing, actually. Really? Really? There it goes.
CES isn't just about what's next. It's about what's possible. Just advancing. And when technology and humanity intersect, the answer is anything.
Anything.
That's because tech doesn't just solve challenges. It transforms them into opportunities. It helps us move smarter, live healthier, and experience the world in ways we never thought possible. We are not just here for a
No
tech
thanks.
event. We're here to connect, to solve, to discover, together. Tech isn't just advancing, it's uniting. Bringing us closer to an autonomous future. Connecting us to better care. Making life more connected, more dynamic,
is-
and in this celebration
Uh-oh.
of what today's challenges demand
I think
bold
Twitch might be a little bit
solutions.
ahead.
And CES is where they start to take shape. Breakthroughs in sustainability. Advancements to help feed our growing world. This week isn't just a stage for breakthroughs. It's the spark for discovery.
Wait, are these the same
Every
stream?
screen,
Oh,
every
no.
pixel, every
He
part
is.
of the tech you will see here.
Okay.
Showcase
Yeah, Twitch is ahead, so we're going to this.
I'm Gary Shapiro, CEO and Vice Chairman of the Consumer Technology Association, the producer of CES, and I am so thrilled to kick off this show with
Sir?
a keynote by one of the most consequential companies in the world.
Sir, you don't have a lot of the
NVIDIA
best.
exemplifies the cutting-edge innovation we celebrate at CES. And founder and CEO Jensen
Okay, you
Huang
should have
is a
the-
true visionary,
You need
demonstrating
the
power of
reading
ideas,
monitor
technology,
at
and
a different
conviction
angle
to
so you're
drive
not
innovation
staring at the ground.
and reshape our industry and our society. I always like to say that if I'd listened a little bit more closely the
What do you
last
like
time
to say?
Jensen spoke at a CTA event, I could have retired already. But over the past 3 decades,
got the best man
he has
speech down.
established NVIDIA as a force driving change across the globe in industries ranging from healthcare to automotive and entertainment. Today, NVIDIA is pioneering breakthroughs in AI and accelerated computing that touch nearly every person and every business. Thanks
Okay.
to his leadership,
I-
NVIDIA's innovations enable advanced chatbots,
Okay.
robots, software-defined vehicles, huge virtual worlds, hyper-synchronized factory floors, and so much more. Wang has been named the world's best CEO by Fortune and The Economist, as well as one of Time
Jensen
Magazine's
really doesn't need a
100 most influential people in the world. But you know, the fact is, like for all of us in this room, our success and his success was not preordained. Jensen started out working at a Denny's as a dishwasher and a busboy, so be nice to them in the future.
Wow, really? As
and
a
he
dishwasher?
said that the lessons he's learned there, the value of hard work, humility, and hospitality are what helped him keep the faith
like the
and
thing you just
persevere through
laughed
some
at.
of NVIDIA's early challenges. In just a few minutes, we'll hear from NVIDIA founder and CEO Jensen Huang on his unwavering vision of the future and where we're headed next. Stay tuned and have a great CES.
Cool. That was way too long. What do you mean a few minutes? Where's Jensen? Did somebody not turn his AI chip on? God damn it. Are you serious right now? Heard the silence the devices thing.
This is the extraordinary
No,
potential.
I don't want to listen to you. You're behind. It's taking a while. What do I got for notifications? Oh, the collaboration thing. Oh, here it goes. I don't know what historical information. Okay. Contains several sequences of quick flashing lights, cause discomfort. Oh, okay, that's good. Well, it's not good. That's like it's good that they warn people. Let's do it. Come on, I want to see it. Or it was just okay. I thought it was about to start, but then they just debated us again. Okay. Taking longer than I thought. Oh, oh, oh. Here we go, here we go.
This is how intelligence is made.
Okay.
A new kind of factory. Generator of tokens. The building blocks of AI. Tokens have opened a new frontier, the first step into an extraordinary world, where endless possibilities are born. Tokens transform words into knowledge and breathe life into images.
Whoa.
They turn ideas into videos and
They've
help us
actually
safely
begun this.
navigate any environment. Tokens teach robots to move like the masters. Inspire new ways to celebrate our victories.
A martini, please.
Coming right up.
Thank you, Adam.
Rich tech robotics.
And give us peace of mind when we need
Okay.
it most.
Hi,
What?
Roka.
The
Hi, Anna.
fuck?
It's good to see you again.
Hi, Emma. We're gonna take your blood sample today, okay?
Don't worry, I'm gonna be here the whole time.
They bring meaning to numbers
Okay.
to help us better understand the world around us.
Turn it down a little bit. Not much, but
Predict the dangers that surround us.
yeah. AI
And
is
find
insane,
cures
man.
for the threats within us.
It's crazy what you can do, and it's scary what you can do.
Tokens can bring our visions to life. And restore what we've lost.
Zachary, I got my voice back, buddy.
They help us move forward. One small step at a time.
Damn.
And one giant leap. Together.
That's how that goes. We in space.
And here is where it all begins.
Everybody holds up their phone. Bring him out. Come on.
Welcome to the stage, NVIDIA founder and CEO,
There he is.
Jensen Huang.
There's the jacket. Wait a minute. That's not the same jacket.
Welcome to CES! Are you excited to be in Las Vegas? Do you like my jacket? I thought I'd go the other way from Gary Shapiro. I'm in Las Vegas after all. If this doesn't work out, if all of you object,
I object.
well, just get used to it. I really think you have to let this sink in.
Uh-huh.
In another hour or so, you're gonna feel good about it.
Oh, okay, okay. All right.
Well, welcome to NVIDIA. In fact, you're inside NVIDIA's digital twin. And we're going to take you to NVIDIA. Ladies and gentlemen, welcome to NVIDIA.
Okay.
You're inside our digital twin. Everything here is generated by AI.
Okay.
It has been an extraordinary journey, extraordinary year. And
I don't understand
it
what's...
started in 1993. Ready, go! With NV1.
Okay.
We
But
wanted
why
to
was it
build
generated by
computers
AI?
that can do things that normal computers couldn't. And NV1 made it possible to have a game console in your PC. Our programming architecture was called UDA, missing the letter C until a little while later, but UDA, Unified Device Architecture. And the first developer for UDA and the first application that ever worked on UDA was Sega's Virtual Fighter. 6 years later, we invented, in 1999, the programmable GPU. And it started 20 plus years of incredible advance in this incredible processor called the GPU. It made modern computer graphics possible. And now, 30 years later,
4080.
Sega's Virtual Fighter is completely cinematic. This is the new Virtual Fighter project that's coming. I just can't wait. Absolutely.
Oh, it's
incredible.
on a 4080. I got it.
6 years after that, 6 years after 1999, we invented CUDA so that we could explain or express the programmability of our GPUs to a rich set of algorithms that could benefit from it. CUDA initially was difficult to explain.
Yeah.
It took years, in fact. It took approximately 6 years. Somehow, 6 years later or so, 2012, Alex Karshevsky, Ilya Sutskever, and Jeff Hinton discovered CUDA, used it to process AlexNet, and the rest of it is history. AI has been advancing at an incredible pace since.
Fucking
Started
crazy.
with perception AI. We now can understand images and words and sounds.
No, he was late because they couldn't find.
Generative AI. We can generate images and text and sounds.
Wait a minute, he's got a wiring on.
And now, agentic AI. AIs that can perceive, reason, plan, and act.
That man got a wire
And
in
the
his
next
back,
phase,
and it don't look like a
something
mic
we'll
wire.
talk about tonight, physical AI, 2012. Now, magically, 2018, something happened that was pretty incredible. Google's Transformer
Not a
was
mic.
released as BERT, and the world of AI really took off. Transformers, as you know, completely changed the landscape for artificial intelligence.
You gotta.
In fact, it completely changed the landscape for computing altogether. We recognized properly that AI was not just a new application with a new business opportunity, but AI, more importantly, machine learning enabled by transformers, was going to fundamentally change how computing works. And today, computing is revolutionized in every single layer, from hand coding, instructions that run on CPUs to create software tools that humans use. We now have machine learning that creates and optimizes neural networks that processes on GPUs and creates artificial intelligence. Every single layer of the technology stack has been completely changed. An incredible transformation in just 12 years. Well, we can now understand information of just about any modality. Surely you've seen text and images and sounds and things like that. But not only can we understand those, we can understand amino acids, we can understand physics. We understand them, we can translate them, and generate them. The applications are just completely endless. In fact, almost any AI application that you see out there, what modality is the input that it learned from? What modality of information did it translate to? And what modality of information is it generating? If you ask these three fundamental questions, just about every single application could be inferred. And so when you see application after applications that are AI driven, AI native, at the core of it, this fundamental concept is there. Machine learning has changed how every application is going to be built, how computing will be done, and the possibilities beyond. Well, GPUs, GeForce, in a lot of ways, all of this with AI is the house that GeForce built. GeForce enabled AI to reach the masses. And now, AI is coming home to GeForce. There are so many things that you can't do without AI. Let me show you some of it now.
Okay. Rendered in real time. Damn. Neural material, 16 megs of memory. Scanner material, 47 megs. Wow. You can definitely tell that part's AI. Barely.
That was real-time computer graphics.
That's crazy.
No computer graphics researcher, no computer scientist would have told you that it is possible for us to ray trace every single pixel at this point. Ray tracing is a simulation of light. The amount of geometry that you saw was absolutely insane. It would have been impossible without artificial intelligence. There are two fundamental things that we did. We used, of course, programmable shading and ray traced acceleration to produce incredibly beautiful pixels. But then we have artificial intelligence be conditioned, be controlled by that pixel to generate a whole bunch of other pixels. Not only is it able to generate other pixels spatially, because it's aware of what the colors should be, it has been trained
there it goes.
on a supercomputer back in NVIDIA, and so the neural network that's running on the GPU can infer and predict the pixels that we did not render. Not only can we do that, it's called
keep
DLSS.
an eye on their main website for the stats.
The latest generation of DLSS also generates beyond frames. It can predict the future, generating 3 additional frames for every frame that we calculate.
Yep.
What you saw, if we just said 4 frames of what you saw, because we're going to render 1 frame and generate 3, if I said 4 frames at full HD, 4K, that's 33 million pixels or so.
It's on HD, but
out of that 33 million pixels, we computed only 2.
What?
It is an absolute miracle that we can computationally using programmable shaders and our ray tracing engine, to compute 2 million pixels and have AI predict all of the other 33. And as a result, we're able to render at incredibly high performance because AI does a lot less computation. It takes, of course, an enormous amount of training to produce that, but once you train it, the generation is extremely efficient. So this is one of the incredible capabilities of artificial intelligence, and that's why there's so many amazing things that are happening. We used GeForce to enable artificial intelligence, and now artificial intelligence is revolutionizing GeForce. Everyone, today we're announcing our next generation, the RTX Blackwell family. Let's take a look.
Ooh, here we go. Here it comes. Right, it's the actual card reveal. 4,000 AI. Right.
Here it is.
Whoa, where? Wait.
Our brand
Holy
new
fuck, that's big.
GeForce RTX 50 series Blackwell architecture. The GPU is just a beast. 92 billion transistors, 4,000 tops, 4 petaflops of AI, 3 times higher than the last generation Ada. And we need all of it to generate those pixels that I showed you. 380 ray tracing teraflops so that we could, for the pixels that we have to compute the most beautiful image you possibly can. And of course, 125 shader teraflops.
RTX.
There's actually a concurrent shader teraflops as well as an integer unit of equal performance. So 2 dual shaders. One is for floating point, one is for integer. G7 memory from Micron. 1.8 terabytes
Holy
per
fuck.
second, twice the performance of our last generation.
I was going to say, that's
and
twice.
we now have the ability to intermix AI workloads with computer graphics workloads. And one of the amazing things about this generation is the programmable shader is also able to now process neural networks. So the shader is able to carry these neural networks, and as a result, we invented neural texture compression and neural material shading. As a result of that, you get these amazingly beautiful images that are only possible because we use AIs to learn the texture, learn the compression algorithm, and as a result, get extraordinary results. Okay, so this is the brand new RTX Blackwell 5090. Now, even the mechanical design is a miracle. Look at this, it's got 2 fans. This whole graphics card is just one giant fan. You know, so the question is, where's the graphics card? It's literally this big. The voltage regulator design is state-of-the-art, incredible design. The engineering team did a great job. So here it is. Thank you. Okay, so those are the speeds and feeds, so how does it compare? Well, this is RTX 4090. I know many of you have one. I know it. Look, it's $1,599. It is one of the best investments you could possibly make. For $1,599, you bring it home to your $10,000 PC entertainment command center. Isn't that right?
No.
Don't tell me that's not true. Don't be ashamed. It's liquid cooled, fancy lights all over it. You lock it when you leave. It's the modern home theater. It makes perfect sense. And now for $1,500 and $1,599, you get to upgrade that and turbocharge the living daylights out of it. Well, now with the Blackwell family, RTX 5070, 4090 performance at $549.
That's not bad. That's pretty fucking crazy.
Impossible without artificial intelligence. Impossible without
God damn it, I fucked it up.
4 teraops of AI tensor cores. Impossible without the G7 memories. Okay, so 5070, 4090 performance, $549, and here's the whole family. Starting from 5070 all the way up to 5090. 5090, twice the performance of a 4090.
No, on the cards that they're pushing out the prices for.
Of course, we're producing at very large scale availability starting January. Well, it is incredible, but we managed to put these in gigantic performance GPUs into a laptop. This is a 5070 laptop. For $1,299,
that's crazy
this
to have that in a
5070 laptop has a 4090 performance. I think there's one here somewhere. Let me show you this. This is look at this thing. Here, here.
It's fucking crazy that they fit
Only so many
that
pockets.
in that.
Ladies and gentlemen, Janine Paul. So can you imagine?
Oops.
You got this incredible graphics card here, Blackwell. We're going to shrink it and put it in there. Does that make any sense? Well, you can't do that without artificial intelligence. And the reason for that is because we're generating most of the pixels using our tensor cores. So we ray trace only the pixels we need, and we generate using artificial intelligence all of the other pixels we have. As a result, the energy efficiency is just off the charts. The future of computer graphics is neural rendering, the fusion of artificial intelligence and computer graphics. And what's really amazing is, oh, here we go. Thank you. This is a surprisingly kinetic keynote. And what's really amazing is the family of GPUs we're going to put in here. And so the 5090 will fit into a laptop, a thin laptop. That last laptop was 14.9 millimeters. We got a 5080, 5070 Ti, and 5070. Okay, so ladies and gentlemen, the RTX Blackwell family.
That's crazy.
Well, GeForce brought AI to the world, democratized
What
AI.
is the 3 times
Now
data,
AI
2
has
times
come
data
back
thing?
and revolutionized GeForce. Let's talk about artificial intelligence. Let's go to somewhere else at NVIDIA. This is literally our office. This is literally NVIDIA's headquarters. Okay, so let's talk about AI. The industry is chasing and racing to scale artificial intelligence. And the scaling law is a powerful model. It's an empirical law that has been observed and demonstrated by researchers and industry over several generations. And the scaling law says that the more data you have, the training data that you have, the larger model that you have, and the more compute that you apply to it, therefore, the more effective or the more capable your model will become. And so the scaling law continues. What's really amazing is that now we're moving towards, of course, and the internet is producing about twice the amount of data every single year as it did last year. I think in the next couple of years humanity will produce more data than all of humanity has ever produced.
Yeah,
since the
probably.
beginning. And so
I've been
we're
joking
still
about that.
producing a gigantic amount of data, and it's becoming multimodal. Video and images and sound, all of that data could be used to train the fundamental knowledge, the foundational knowledge of an AI. But there are, in fact, 2 other scaling laws that has now emerged. And it's somewhat intuitive. The second scaling law is post-training scaling law.
Interesting.
Post-training scaling law uses techniques like reinforcement learning, human feedback. Basically, the AI produces and generates answers based on a human query. The human then, of course, gives a feedback. It's much more complicated than that, but that reinforcement learning system with a fair number of very high-quality prompts causes the AI to refine its skills. It could fine-tune its skills for particular domains. It could be better at solving math problems, better at reasoning, so on and so forth. And so it's essentially like having a mentor or having a coach give you feedback after you're done going to school. And so you get tests, you get feedback, you improve yourself. We also have reinforcement learning AI feedback, and we have synthetic data generation. These techniques are rather akin to, if you will, self-practice. You know the answer to a particular problem, and you continue to try it until you get it right. And so an AI could be presented with a very complicated and a difficult problem that is verifiable.
Trying to find good 4090 specs here.
And it has an answer that we understand. Maybe proving a theorem, maybe solving a geometry problem. And so these problems would cause the AI to produce answers, and using reinforcement learning, it would learn how to improve itself. That's called post-training. Post-training requires an enormous amount of computation, but the end result produces incredible models. We now have a third scaling law, and this third scaling law has to do with what's called test time scaling. Test time scaling is basically when you're being used. When you're using the AI has the ability to now apply a different resource allocation. Instead of improving its parameters, now it's focused on deciding how much computation to use to produce the answers it wants to produce. Reasoning is a way of thinking about this. Long thinking is a way to think about this. Instead of a direct inference or one-shot answer, you might reason about it. You might break down the problem into multiple steps. You might generate multiple ideas and evaluate, your AI system would evaluate which one of the ideas that you generated was the best one. Maybe it solves the problem step by step, so on and so forth. And so now test time scaling has proven to be incredibly effective. You're watching this sequence of technology and all of these scaling laws emerge as we see incredible achievements from ChatGPT to O1 to O3 and now Gemini Pro. All of these systems are going through this journey step by step of pre-training to post-training to test time scaling. Well, the amount of computation that we need, of course, is incredible. And we would like, in fact, that society has the ability to scale the amount of computation to produce more and more novel and better intelligence. Intelligence, of course, is the most valuable asset that we have, and it can be applied to solve a lot of very challenging problems. And so, scaling law. It's driving enormous demand for NVIDIA computing. It's driving an enormous demand for this incredible chip we call Blackwell. Let's take a look at Blackwell. Well, Blackwell is in full production. It is incredible what it looks like. So first of all, there's some, every single cloud service provider now have systems up and running. We have systems here from about 15 computer makers. It's being made about 200 different SKUs, 200 different configurations.
This fucking chip is absolutely bonkers.
x86, NVIDIA Grace CPU versions, NVLink 36 by 2, NVLink 72 by 1, whole bunch of different types of systems so that we can accommodate just about every single data center in the world. Well, these systems are being currently manufactured in some 45 factories. It tells you how pervasive artificial intelligence is and how much the industry is jumping onto artificial intelligence in this new computing model. Well, the reason why we're driving it so hard is because we need a lot more computation.
I gotta get one of these, man.
It's very
the
clear
specs on this are bonkers. Uh-oh. Happened something break? Uh-oh. Who's getting in trouble? Oh, okay. I thought he was waiting for somebody.
It's hard to tell. You don't ever want to reach your hands into a dark place. Hang on a second. Is this a good idea?
What are you doing? Don't. Okay. I saw that coming. What?
Wait for it. Wait for it. I thought I was worthy. Apparently, Yonir didn't think I was worthy. All right. This is my show and tell. This is a show and tell. So, this NVLink system, this right here, this NVLink system, this is GB200 NVLink 72. It is 1.5 tons, 600,000 parts, approximately equal to 20 cars.
That's fucking bonkers.
120 kilowatts.
Holy fuck.
It has a spine behind it that connects all of these GPU together, 2 miles of copper cable, 5,000 cables. This is being manufactured in 45 factories around the world. We build them, we liquid cool them,
NVLink 72. That's
we disassemble them, ship them in parts to the data centers because it's 1.5 tons. We reassemble it outside the data centers and install them. The manufacturing is insane.
It's not Grays.
But the goal of all of this is because the scaling laws are driving computing so hard that this level of computation, Blackwell over our last generation, improves the performance per watt by a factor of 4. Performance per watt
there's too
by
many
a factor
numbers.
of
My
4.
brain is lost.
Performance per dollar.
Hang on, I want
by
to show you
a
guys
factor of
this.
3. That basically says that in one generation,
Okay.
we reduce
So
the cost of training these models by a factor of 3.
he's talking about a lot of stuff right now.
Or if you want to increase,
This is the
size of your
specs
model
of the
by a factor of 3,
5090,
it's
like
about
off
same
the
cost.
cuff, right?
But the important thing is this: these are generated
This
tokens that are being used
is the
by all
cuff,
of us
off the cuff,
when we use
original
ChatGPT
slide of
or
the
when we use
4090.
Gemini, use our phones in the future. Just about
This
all of these
card
applications
has
gonna be
almost
consuming
twice the
these
memory
AI tokens.
bandwidth.
And these AI
Has
tokens are being
1.8
generated by these systems.
versus.
And every single data center
Is that not on this
is
picture?
limited by power. And so if the perf per watt of Blackwell is 4 times our last generation,
Hang on, let me
then
move this over
the
here.
revenue that
I
can
took
be
a picture.
generated, the amount of business that can be generated in the
4090
data centers increased
was
by a factor of 4. And so these AI factory
1.01
systems really are factories today.
or memory
Now the
bandwidth.
goal of all of this is so that we can create one giant chip.
92 billion transistors.
The amount of computation we need is really quite incredible. And this is
76
basically
billion.
one giant chip. If we would have had to build a chip, here we go. Sorry, guys.
90
You see that? That's
shader
cool.
P-flops.
Look at that, disco lights in here.
125.
If we had to build this as one chip, obviously this would be the size of the wafer, but this doesn't include
This,
the impact
the
of
original
yield.
4090,
It would have to be probably 3 or 4 times the size.
200 ray
But
trace
what we basically
T-flops,
have
right?
here is 72 Blackwell GPUs,
380.
or 144 dies.
I don't
This
even know what
one
AI tops
chip
is.
here is 1.4 exaflops. The world's
I'm
largest
sorry?
supercomputer, fastest supercomputer, only
Holy shit.
recently, this entire room supercomputer only recently achieved an exaflop plus. This is 1.4 exaflops of AI floating point performance. It has 14 terabytes of memory, but here's the amazing thing. The memory bandwidth is 1.2 petabytes per second. That's basically the entire internet traffic that's happening right now. The entire world's internet
Blackwell.
traffic is being processed across these chips.
That's
Okay?
fucking
And we have,
insane.
130 trillion transistors in total, 2,592 CPU cores, whole bunch of networking. And so these, I wish I could do this. I don't think I will. So these are the Blackwells. These are our ConnectX.
God, please don't tell me it's an actual. There's
Networking
no way it's an
chips.
actual chip, right?
These are the NVLink, and we're trying to pretend about the NVLink spine, but that's not possible. Okay. And these are all of the
Okay.
HBM memories.
Okay.
14 terabytes.
You
of
say
HBM
that
memory.
chip has got to be.
This is what we're trying to do. And
bonkers
this
expensive.
is the miracle. This is the miracle of the Blackwell system. The Blackwell dies right here. It is the largest single chip the world's ever made. But yet, the miracle is really, in addition to
Stop
that,
talking. Try to hear
this
revenue.
is, the great
Sorry.
Blackwell system. Well, the goal of all of this, of course, is so that we can. Thank you. Thanks. Boy, is there a chair I could sit down for a second?
Got something in his jacket.
Can I have a Michelob Ultra? How is it possible that we're in the Michelob Ultra Stadium? It's like coming to NVIDIA and we don't have a GPU for you.
True.
So we need an enormous amount of computation, because we want to train larger and larger models. And these inferences used to be one inference, but in the future, the AI is going to be talking to itself. It's going to be thinking. It's going to be internally reflecting, processing. So today, when the tokens are being generated at you, so long as it's coming out at 20 or 30 tokens per second, it's
he
basically
was late
as fast
with
as
his
anybody can read.
jacket.
However, in the future, and right now with
But there's like
GPT-01,
something special about it
you know,
because he's
with-
got a
with the
wire
new-
hanging out the back of it too.
Gemini Pro and the new
He made a
01,
joke about it
03
too.
models, they're talking to themselves, reflecting, they're thinking. And so, as you can imagine, the rate at which the tokens could be ingested is incredibly high. And so we need the token rates, the token generation rates, to go way up. And we also have to drive the cost way down simultaneously so that the quality of service can be extraordinary, the cost to customers can continue to be low, and AI will continue to scale. And so that's the fundamental purpose, the reason why we created NVLink. Well, one of the most important things that's happening in the world of enterprise is agentic AI. Agentic AI basically is a perfect example of test time scaling. AI is a system of models. Some of it is understanding, interacting with the customer, interacting with the user. Some of it's maybe retrieving information from storage, a semantic
God,
AI
I wish I
system,
was there.
like a RAG. Maybe it's going on to the internet. Maybe it's studying a PDF file. And so it might be using tools, it might be using a calculator, and it might be using a generative AI to generate charts and such. And it's taking the problem you gave it, breaking it down step by step, and it's iterating through all these different models. Well, in order to respond to a customer in the future, in order for AI to respond, it used to be ask a question, answer starts spewing out. In the future, you ask a question, a whole bunch of models are going to be working in the background. And so test time scaling, the amount of computation used for inferencing is going to go through the roof. It's going to go through the roof because we want better and better answers. Well, to help the industry build agentic AI, our go-to-market is not direct to enterprise customers. Our go-to-market is.
Are they going to talk
we
about the
work with
5090s
software
at all
developers
anymore,
in
or like the
IT
5000 series, or was it
ecosystem
just this
to
like,
integrate
bam,
our
here's the stats?
technology
I think they did this last
to
time.
make possible new capabilities, just like we did with CUDA libraries. We now want to do that with AI libraries. And just as the computing model of the past has APIs that are doing computer graphics or doing linear algebra or doing fluid dynamics, in the future, on top of those acceleration libraries, CUDA acceleration libraries, we'll have AI libraries. We've created 3 things for helping the ecosystem build agentic AI. NVIDIA NIMs, which are essentially AI microservices all packaged up. It takes all of this really complicated CUDA software, CUDA DNN, Cutlass, or TensorRT-LM, or Triton, or all of these different really complicated software, and the model itself, we package it up, we optimize it, we put it into a container, and you could take it wherever you like. And so we have models for vision, for understanding languages, for speech, for animation, for digital biology, and we have some new exciting models coming for physical AI. And these AI models run in every single cloud because NVIDIA's GPUs are now available in every single cloud. It's available in every single OEM. So you could literally take these models, integrate it into your software packages, create AI agents that run on Cadence, or they might be ServiceNow agents, or they might be SAP agents, and they could deploy it to their customers and run it wherever the customers want to run.
I'll turn this up a little bit more.
The next layer is what we call NVIDIA NeMo. NeMo is essentially a digital employee onboarding and training evaluation system. In the future, these AI agents are essentially digital workforce that are working alongside your employees, doing things for you on your behalf. And so the way that you would bring these specialized agents these special agents into your company is to onboard them, just like you onboard an employee. And so we have different libraries that helps these AI agents be trained for the type of language in your company. Maybe the vocabulary is unique to your company. The business process
they're
is different.
breaking
The way you
down
work is
the
different.
humanized
You would give them examples
workforce
of what the
into
work
like
product should look
a
like.
folder
And
of
they would try to
this is your
generate it. And
job,
you would give it feedback.
and using
you
that
would
for the
evaluate
AI.
them, so on and so forth. And so that and you would guardrail them. You say, these are the things that you're not allowed to do. These are the things you're not allowed to say. And we even give them access to certain information. Okay, so that entire pipeline, digital employee pipeline, is called NEMO. In a lot of ways, the IT department of every company is going to be the HR department of AI agents in the future. Today, they manage and maintain a bunch of software from the IT industry. In the future, they'll maintain, nurture, onboard, and improve a whole bunch of digital agents and provision them to the companies to use. Okay, and so your IT department is going to become kind of like AI agent HR. And on top of that, we provide a whole bunch of blueprints that our ecosystem could take advantage of. All of this is completely open source, and so you could take it and modify the blueprints. We have blueprints for all kinds of different types of agents. Well, today we're also announcing that we're doing something that's really cool and I think really clever. We're announcing a whole family of models that are based off of Llama, the NVIDIA Llama Nemotron language foundation models. Llama 3.1
wow, that's a lot.
is a complete phenomenon.
Nemotron.
The download of Llama 3.1 from Meta, 650,000 times, something like that. It has been derived and turned into other models, about 60,000 other different models. It is singularly the reason why just about every single enterprise and every single industry has been activated to start working on AI. Well, the thing that we did was we realized that the Llama models really could be better fine-tuned for enterprise use. And so we fine-tune them using our expertise and our capabilities, and we turn them into the Llama
God,
Nemotron
I want one of these cards so bad.
Open models. There are small ones that interact in very, very fast response time, extremely small. They're what we call super Llama Nemotron supers. They're basically your mainstream versions of your models. Or your ultra model. The ultra model could be used to be a teacher model for a whole bunch of other models. It could be a reward model, evaluator, a judge for other models to create answers and decide whether it's a good answer or not, basically give feedback to other models. It could be distilled in a lot of different ways. Basically, a teacher model, a knowledge distillation model. Very large, very capable. And so all of this is now available online. Well, these models are incredible. It's number one in leaderboards.
Okay, so we're going to take a look at their website real quick.
Leaderboard for
they updated their website.
Leaderboard for retrieval. So the different types of functionalities necessary that are used in AI agents around the world.
We're going to scan this real quick.
These are going to be incredible models for you.
Ray trace cores, two
We're
times the
also
ray
working
triangle.
with the ecosystem. All of our NVIDIA AI technologies are integrated into the IT industry. We have great partners and really great work
Gen
being done at
5
ServiceNow,
DisplayPort
at
2.1B.
SAP, at Siemens for industrial AI. Cadence is doing great work. Synopsys is doing great work. I'm really proud of the work that we do with Perplexity. As you know, they revolutionized search. Yeah, really fantastic
not only
stuff.
that, but we will be getting DLSS 4.
Every software engineer in the world. This is going to be the next
32
giant
gigs.
AI application. Next giant AI service, period, is software coding. 30 million software engineers around the world.
That's insane, the difference.
Everybody is going to have a software assistant helping them code. If not, obviously you're going to be way less productive.
January 30th.
Create lesser good code. And so this is 30 million. There's 1 billion knowledge workers in the world. It is very, very clear AI agents is probably the next robotics industry and likely to be a multi-trillion-dollar opportunity. Well, let me show you some of the blueprints that we've created and some of the work that we've done with our partners with these AI agents. AI agents are the new digital workforce, working for and with us.
Why is it so loud?
AI agents are a system of models that reason about a mission, break it down into tasks, and retrieve data or use tools to generate a quality response. NVIDIA's agentic AI building blocks, NIM pre-trained models, and NEMO framework let organizations easily develop AI agents and deploy them anywhere.
We will onboard and train our agentic workforces on our company's methods, like we do for employees. AI agents are domain-specific task experts. Let me show you 4 examples. For the billions of knowledge workers and students, AI research assistant agents ingest complex documents like lectures, journals, financial results, and generate interactive podcasts for easy learning.
By combining a UNet regression model with a diffusion model, CoreDiff can downscale global weather forecasts down from 25 kilometers to 2 kilometers.
Developers, like at NVIDIA, manage software security AI agents that continuously
I
scan
don't know about
software for
this.
vulnerabilities,
Like,
alerting developers to what action is needed. Virtual lab AI agents help researchers design and screen billions of compounds to find promising drug candidates faster than ever.
like that's obviously really important.
And
that
video
part.
analytics AI agents built on an NVIDIA Metropolis blueprint, including NVIDIA Cosmos Nematron vision language models, Llama Nematron LLMs, and Nemo Retriever. Metropolis agents analyze content from the
man.
billions of cameras generating 100,000 petabytes of video per day. They enable interactive search, summarization, and automated reporting, and help monitor traffic flows, flagging congestion or danger. In industrial facilities, they monitor processes and generate recommendations or improvement. Metropolis agents centralize data from hundreds of cameras and can reroute workers or robots when incidents occur. The age of agentic AI is here, for every organization.
Okay. That was the first pitch at a baseball game. That was not generated. I just felt that none of you were impressed. Okay, so AI was created in the cloud and for the cloud. AI is created in the cloud and for the cloud. And for enjoying AI on phones, of course, it's perfect. Very, very soon, we're going to have a continuous AI that's going to be with you. And when you use those Meta glasses, you could, of course, point at something, look at something, and ask it, whatever information you want. And so AI is perfect in the cloud. It was created in the cloud, it's perfect in the cloud. However, we would love to be able to take that AI everywhere. I've mentioned already that you could take NVIDIA AI to any cloud, but you could also put it inside your company. But the thing that we want to do more than anything is put it on our PC as well.
Yes.
And so, as you know, Windows 95 revolutionized the computer industry. It made possible this new suite of multimedia services, and it changed the way that applications was created forever. Windows 95, this model of computing, of course, is not perfect for AI. And so the thing that we would like to do is we would like to have in the future your AI basically become your AI assistant. And instead of just the 3D APIs and the sound APIs and the video APIs, you would have generative APIs for 3D and generative APIs for language and generative AI for
5080 and
sound and so on and so
5090.
And we need a system that makes that possible while leveraging the massive investment that's in the cloud. There's no way that the world can create yet another way of programming AI models. It's just not going to happen. And so if we could figure out a way to make Windows PC a world-class AI PC, it would be completely awesome. And it turns out the answer is Windows. It's Windows WSL2. Windows WSL2.
What?
Windows WSL2 basically is 2 operating systems within one. It works perfectly. It's developed for developers, and it's developed so that you can have access to bare metal. WSL2 has been optimized for cloud-native applications. It is optimized for, and very importantly, it's been optimized for CUDA. And so WSL2 supports CUDA perfectly out of the box. As a result, everything that I showed you with NVIDIA NIMS, NVIDIA NEMO, the blueprints that we developed that are going to be up in ai.nvidia.com, so long as the computer fits it, so long as you can fit that model And we're going to have many models that fit, whether it's vision models or language models or speech models or these animation, digital human models. All kinds of different types of models are going to be perfect for your PC. And you download it and it should just run. And so our focus is to turn Windows WSL2, Windows PC, into a target first-class platform that we will support and maintain for as long as we shall live. And so this is an incredible thing for engineers and developers everywhere. Let me show you something that we can do with that. This is one of the examples of a blueprint we just made for you.
Generative AI synthesizes amazing images from simple text prompts. Yet image composition can be challenging to control using only words. With NVIDIA NIM microservices, creators can use simple 3D objects to guide AI image generation. Let's see how a concept artist can use this technology to develop the look of a scene. They start by laying out 3D assets, created by hand or generated with AI. Then use an image generation NIM, such as Flux, to create a visual that adheres to the 3D scene. Add or move objects to refine the composition. Change camera angles to frame the perfect shot. Or reimagine the whole scene with a new prompt.
Wow.
Assisted by generative AI and NVIDIA NIM, an artist can quickly realize their vision.
NVIDIA AI for your PCs.
That's crazy.
Hundreds of millions of PCs in the world with Windows, and so we could get them ready for AI. OEMs, all the PC OEMs we work with, just basically all of the world's leading PC OEMs, are going to get their PCs ready for this stack. And so AI PCs are coming to a home near you. Linux is good. Okay, let's talk about physical AI. Speaking of Linux, let's talk about physical AI. So, physical AI. Imagine, whereas your large language model, you give it your context, your prompt on the left, and it generates tokens one at a time to produce the output. That's basically how it works. The amazing thing is, this model in the middle is quite large, has billions of parameters. The context length is incredibly large because you might decide to load in a PDF. In my case, I might load in several PDFs before I ask it a question. Those PDFs are turned into tokens. The basic attention characteristic of a transformer has every single token find its relationship and relevance against every other token. So you could
the word
have
tokens
hundreds
worries
of thousands
me.
of tokens, and the computational load increases quadratically. And it does this, all of the parameters, all of the input sequence, process it through every single layer of the transformer, and it produces one token. That's the reason why we needed Blackwell. And then the next token is produced when the current token is done. It puts the current token into the input sequence and takes that whole thing and generates the next token. It does it one at a time. This is the transformer model. It's the reason why it is so incredibly effective, computationally demanding. What if instead of PDFs, it's your surrounding? And what if instead of the prompt, a question, it's a request? Go over there and pick up that, that box and bring it back. And instead of what is produced in tokens as text, it produces action tokens. Well, that I just described is a very sensible thing for the future of robotics. And the technology is right around the corner. But what we need to do is we need to create the effectively the world model of, as opposed to GPT, which is a language model. And this world model has to understand the language of the world. It has to understand physical dynamics, things like gravity and friction and inertia. It has to understand geometric and spatial relationships. It has to understand cause and effect. If you drop something, it falls to the ground. If you poke at it, it tips over. It has to understand object permanence. If you roll a ball over the kitchen counter, when it goes off the other side, the ball didn't leave into another quantum universe. That's still there. And so all of these types of understanding is intuitive understanding that we know that most models today have a very hard time with. And so we would like to create a world, we need a world foundation model. Today we're announcing a very big thing. We're announcing NVIDIA Cosmos, a world foundation model that is designed, that was created to understand the physical world. And the only way for you to really understand this is to see it. Let's play it.
The next frontier of AI is physical AI. Model performance is directly related to data availability, but physical world data is costly to capture, curate, and label.
Yeah.
NVIDIA Cosmos is a world foundation model development platform to advance physical AI. It includes auto-regressive world foundation models, diffusion-based world foundation models, advanced tokenizers, and an NVIDIA CUDA, an AI-accelerated data pipeline. Cosmos models ingest text, image, or video prompts and generate virtual world states as videos. Cosmos generations prioritize the unique requirements of AV and robotics use cases, like real-world environments, lighting, and object permanence. Developers use NVIDIA Omniverse to build physics-based, geospatially accurate scenarios, then output Omniverse renders into Cosmos, which generates photoreal, physically based synthetic data. Whether diverse objects or environments, conditions like weather or time of day, or edge case scenarios. Developers use Cosmos to generate worlds for reinforcement learning AI feedback to improve policy models, or to test and validate model performance, even across multi-sensor views. Cosmos can generate tokens in real time, bringing the power of foresight and multiverse simulation to AI models, generating every possible future to help the model select the right path. Working with the world's developer
That's
ecosystem,
kind of scary.
NVIDIA is helping advance the next wave of physical AI.
NVIDIA Cosmos. NVIDIA Cosmos.
That's crazy.
NVIDIA Cosmos, the world's first world foundation model. It is trained on 20 million hours of video. The 20 million hours of video focuses on physical dynamic things. So dynamic nature themes, humans walking, hands moving, manipulating things, things that are fast camera movements. It's really about teaching the AI, not about generating creative content, but teaching the AI to understand the physical world. And from this, with this physical AI, there are many downstream things that we could do as a result. We could do synthetic data generation to train models. We could distill it and turn it into effectively the beginnings of a robotics model. You could have it generate multiple physically based, physically plausible scenarios of the future, basically do a Doctor Strange. You could, because this model understands the physical world, of course you saw a whole bunch of images generated, this model understanding the physical world, it also could do, of course, captioning. And so it could take videos, caption it incredibly well, and that captioning and the video could be used to train large language models, multimodality large language models. And so you could use this technology to use this foundation model to train robots, as well as large language models. And so this is the NVIDIA Cosmos. The platform has an autoregressive model for real-time applications, has diffusion model for very high quality image generation. It's incredible tokenizer, basically learning the vocabulary of real world. and a
It's
data
crazy.
pipeline, so that if you would like to take all of this and then train it on your own data, this data pipeline, because there's so much data involved, we've accelerated everything end to end for you. And so this is the world's first data processing pipeline that's CUDA accelerated as well as AI accelerated. All of this is part of the Cosmos platform. And today we're announcing that Cosmos is open licensed. It's open available
Holy
on GitHub.
shit.
We hope that this moment, and there's a small, medium, large for very fast models, mainstream models, and also teacher models, basically not knowledge transfer models. Cosmos World Foundation model being open, we really hope will do for the world of robotics and industrial AI what Llama 3 has done for enterprise AI. The magic happens when you connect Cosmos to Omniverse, and the reason fundamentally is this. Omniverse is a physics grounded, not physically grounded, but physics grounded. It's algorithmic physics, principled physics simulation grounded system. It's a simulator. When you connect that to Cosmos, it provides the grounding, the ground truth that can control and to condition the Osmos generation. As a result, what comes out of Osmos is grounded on truth. This is exactly the same idea as connecting a large language model to a RAG, to a retrieval augmented generation system. You want to ground the AI generation on ground truth. And so the combination of the two gives you a physically simulated, a physically grounded multiverse generator. And the application, the use cases are really quite exciting. And of
Insane.
course, for robotics, for industrial applications, it is very, very clear. This Cosmos plus Omniverse plus Cosmos represents the third computer that's necessary for building robotic systems. Every robotics company will ultimately have to build 3 computers. The robotic system could be a factory, the robotic system could be a car, it could be a robot. You need 3 fundamental computers. One computer, of course, to train the AI. We call it the DGX computer to train the AI. Another, of course, when you're done, to deploy the AI. We call that AGX. That's inside the car, in the robot, or in an AMR, or at the in a stadium, or whatever it is. These computers are at the edge and they're autonomous. But to connect the two, you need a digital twin. And this is all the simulations that you were seeing. The digital twin is where the AI that has been trained goes to practice, to be refined, to do its synthetic data generation, reinforcement learning, AI feedback, such and such. And so it's the digital twin of the AI. These 3 computers are going to be working interactively. NVIDIA's strategy for the industrial world, and we've been talking about this for some time, is this 3-computer system. Instead of a three-body problem, we have a 3-computer solution. And so it's the NVIDIA robotics.
That's crazy.
So let me give you 3 examples. All right, so the first example is how we apply all of this to industrial digitalization. There are millions of factories, hundreds of thousands of warehouses. That's basically the backbone of a $50 trillion manufacturing industry. All of that has to become software defined. All of it has to have automation in the future. And all of it will be infused with robotics. Well, we're partnering with Kion, the world's leading warehouse automation solutions provider, and Accenture, the world's largest professional services provider, and they have a big focus in digital manufacturing. And we're working together to create something that's really special. And I'll show you that in a second. But our go-to-market is essentially the same as all of the other software platforms and all the technology platforms that we have. Through the developers and ecosystem partners, and we have just a growing number of ecosystem partners connecting to Omniverse. And the reason for that is very clear. Everybody wants to digitalize the future of industries. There's so much waste, so much opportunity for automation in that $50 trillion of the world's GDP. So let's take a look at that. This one example that we're doing with Kion and Accenture.
Kion, the supply chain solution company, Accenture, a global leader in professional services, and NVIDIA are bringing physical AI to the $1 trillion warehouse and distribution center market. Managing high-performance warehouse logistics involves navigating a complex web of decisions influenced by constantly shifting variables. These include daily and seasonal demand changes, space constraints, workforce availability, and the integration of diverse robotic and automated systems. And predicting operational KPIs of a physical warehouse is nearly impossible today. To tackle these challenges, Kion is adopting Mega, an NVIDIA Omniverse blueprint for building industrial digital twins to test and optimize robotic fleets. First, Kion's warehouse management solution assigns tasks to the industrial AI brains in the digital twin, such as moving a load from a buffer location to a shuttle storage solution. The robot's brains are in a simulation of a physical warehouse, digitalized into Omniverse using OpenUSD connectors to aggregate CAD, video and image to 3D, LiDAR to point cloud, and AI-generated data. The fleet of robots execute tasks by perceiving and reasoning about their Omniverse digital twin environment, planning their next motion and acting. The robot brains can see the resulting state through sensor simulations and decide their next action. The loop continues while Mega precisely tracks the state of everything in the digital twin. Now, Kion can simulate infinite scenarios at scale while measuring operational KPIs, such as throughput, efficiency, and utilization, all before deploying changes to the physical warehouse. Together with NVIDIA, Kion and Accenture are reinventing industrial autonomy.
The future, that's incredible. Everything is in simulation. In the future, every factory will have a digital twin. And that digital twin operates exactly like the real factory.
Sorry, I'm
and in
screenshotting
fact,
stuff.
You could use Omniverse with Cosmos to generate a whole bunch of future scenarios, and you pick, then an AI decides which one of the scenarios are the most optimal for whatever KPIs, and that becomes the programming constraints, the program, if you will, the AIs that will be deployed into the real factories. The next example, autonomous vehicles. The AV revolution has arrived. After so many years, with Waymo's success and Tesla's success, it is very, very clear autonomous vehicles has finally arrived. Well, our offering to this industry is the three computers, the training systems to train the AIs, the simulation systems, and the synthetic data generation systems, Omniverse and now Cosmos, and also the computer that's inside the car. Each car company might work with us in a different way, use one or two or three of the computers. We're working with just about every major car company around the world. Waymo and Zoox and Tesla, of course, in their data center. BYD, the largest EV company in the world. JLR's got a really cool car coming. Mercedes has a fleet of cars coming with NVIDIA starting this year, going to production. And I'm super, super pleased to announce that today, Toyota and NVIDIA are going to partner together to create their next generation AVs.
Damn. No wonder their stock raised right before this.
Just so many cool companies. Lucid and Rivian and Xiaomi and of course Volvo, just so many different companies. Wabi is building self-driving trucks. Aurora, we announced this week also that Aurora is going to use NVIDIA to build self-driving trucks. Autonomous, 100 million cars built each year, a billion vehicles on the road all over the world, 1 trillion miles that are driven around the world each year. That's all going to be either highly autonomous or, fully autonomous coming up. And so this is going to be a very large industry. I predict that this will likely be the first multi-trillion-dollar robotics industry.
Yeah.
This business for us, notice in just a few of these cars that are starting to ramp into the world, our business is already $4 billion, and this year probably on a run rate about $5 billion. So really significant business already. This is going to be very large. Well, today we're announcing that our next generation processor for the car,
Jesus
our next generation
Christ.
computer for the car is called Thor. I have one right here. Hang on a second. Okay, this is Thor. This is Thor. This is a robotics computer. This is a robotics computer. It takes sensors and just a
Hyperion
madness
9.
amount of sensor information, process it, you know, umpteen cameras, high resolution, radars, lidars, they're all coming into this chip. And this chip has to process all that sensor, turn them into tokens, put them into a transformer, and predict the next path. And this AV computer is now in full production. Thor is 20 times the processing capability of our last generation Orin, which is really the standard of autonomous vehicles today. And so this is just really quite incredible. Thor is in full production. This robotics processor, by the way, also goes into a full robot. And so it could be an AMR, it could be a humanoid robot, it could be the brain, it could be the manipulator. This processor basically is a universal robotics computer.
That's crazy.
The second part of our drive system that I'm incredibly proud of is the dedication to safety. Drive OS, I'm pleased to announce, is now the first software-defined programmable AI computer that has been certified up to ASIL D, which is the highest standard of functional safety for automobiles. The only and the highest. And so I'm really, really proud of this. ASIL D, ISO 26262. It is the work of some 15,000 engineering years. This is just extraordinary
I don't even know what
work. And as a result of that,
ASIL
CUDA is now
is, to be honest.
functional, safe computer. And so if you're building a
Oh.
robot, NVIDIA CUDA, yep. Okay, so now I told you I was going to show you what would we use Omniverse and Cosmos to do in the context of self-driving cars. And you know, today, instead of showing you a whole bunch of videos of cars driving on the road, I'll show you some of that too. But I want to show you how we use the car to reconstruct digital twins automatically using AI and use that capability to train future AI models. Okay, let's play it.
The autonomous vehicle revolution is here. Building autonomous vehicles, like all robots, requires 3 computers: NVIDIA DGX to train AI models, Omniverse to test drive and generate synthetic data, and Drive AGX, a supercomputer in the car. Building safe autonomous vehicles means addressing edge scenarios, but real-world data is limited, so synthetic data is essential for training. The Autonomous Vehicle Data Factory, powered by NVIDIA Omniverse, AI models, and Cosmos, generates synthetic driving scenarios that enhance training data by orders of magnitude. First, OmniMap fuses map and geospatial data to construct drivable 3D environments. Driving scenario variations can be generated from replayed drive logs or AI traffic generators. Next, a neural reconstruction engine uses autonomous vehicle sensor logs to create high-fidelity 4D simulation environments. It replays previous drives in 3D and generates scenario variations to amplify training data. Finally, Edify 3DS automatically searches through existing asset libraries or generates new assets to create sim-ready scenes.
Wow.
The Omniverse scenarios are used to condition Cosmos to generate massive amounts of photorealistic data, reducing the sim-to-real gap. And with text prompts, generate near infinite variations of the driving scenario.
They can literally use this
with Cosmos
AI
Nemotron video search
or
the massively scaled
anything.
Synthetic dataset
When it comes
combined
to
with recorded drives
creating
can be curated to train models. NVIDIA's AI data factory scales
Holy
hundreds
shit.
of drives into billions of effective miles, setting the standard for safe and advanced autonomous driving.
This is the kind of technology they can use
Isn't that
to
incredible?
literally create any kind of like
take
game mechanic that will
thousands
like
of drives
change
and turn them into
create
billions
on the
of
fly.
miles. We are going to have mountains of training data for autonomous vehicles. Of course, we still need actual cars on the road. Of course, we will continuously collect data for as long as we shall live. However, synthetic data generation using this multiverse, physically based, physically grounded capability so that we generate data for training AIs that are physically grounded and accurate and or plausible so that we could have an enormous amount of data to train with. The AV industry is here. This is an incredibly exciting time, super excited about the next several years. I think you're going to see, just as computer graphics was revolutionized such incredible pace, you're going to see the pace of AV development increasing tremendously over the next several years.
Yeah. Oh.
I think the next part is robotics. So
Okay.
humanoid robots, my friends.
Oh God, it's begun.
The ChatGPT moment for general robotics is just around the corner. And in fact, all of the enabling technologies that I've been talking about is going to make it possible for us in the next several years to see very rapid breakthroughs, surprising breakthroughs in general robotics. Now, the reason why general robotics is so important is whereas robots with tracks and wheels require special environments to accommodate them,
Oh
there
God, these
three
are actual.
three robots in the world that we can make that require no green fields. Brownfield adaptation is perfect. If we could possibly build these amazing robots, we could deploy them in exactly the world that we've built for ourselves. These three robots are, one, agentic robots, and agentic AI, because they're information workers. So long as they could accommodate the computers that we have in our offices, it's going to be great. Number two, self-driving cars. And the reason for that is we spent 100+ years building roads and cities. And then number three, humanoid robots. If we have the technology to solve these three, this will be the largest technology industry the world's ever seen. And so we think that the robotics era is just around the corner. The critical capability is how to train these robots. In the case of humanoid robots, the imitation information is rather hard to collect. And the reason for that is, in the case of car, you just drive it. We're driving cars all the time. In the case of these humanoid robots, the imitation information, the human demonstration is rather laborious to do. And so we need to come up with a clever way to take hundreds of demonstrations, thousands of human demonstrations, and somehow use artificial intelligence and Omniverse to synthetically generate millions of synthetically generated motions. And from those motions, the AI can learn how to perform a task. Let me show you how that's done.
Oh God.
Developers around the world are building the next wave of physical, AI-embodied robots, humanoids. Developing general-purpose robot models requires massive amounts of real-world data, which is costly to capture and curate. NVIDIA Isaac GR00T helps tackle these challenges, providing humanoid robot developers with four things: robot foundation models, data pipelines, simulation frameworks, and a Thor robotics computer. The NVIDIA Isaac GR00T blueprint for synthetic motion generation is a simulation workflow for imitation learning, enabling developers to generate exponentially large data sets from a small number of human demonstrations. First, Groot Teleop enables skilled human workers to portal into a digital twin of their robot using the Apple Vision Pro. This means operators can capture data even without a physical robot, and they can operate the robot in a risk-free environment,
So
eliminating the chance of physical damage or wear and tear.
we are training the replacements.
To teach a robot a single task, operators capture motion trajectories through a handful of teleoperated demonstrations. Then use Groot Mimic to multiply these trajectories into a much larger data set. Next, they use Groot Gen, built on Omniverse and Cosmos for domain randomization and 3D to real upscaling.
Yep.
Generating an exponentially larger data set. The Omniverse and Cosmos Multiverse Simulation Engine provides a massively scaled data set to train the robot policy. Once the policy is trained, developers can perform software-in-the-loop testing and validation in Isaac Sim before deploying to the real robot. The age of general robotics is arriving, powered by NVIDIA Isaac Groot.
We're going to have mountains of data to train robots with. NVIDIA Isaac Groot. NVIDIA Isaac Groot. This is our platform to provide technology elements to the robotics industry to accelerate the development of general robotics. And well, I have one more thing that I want to show you. None of this would be possible if not for this incredible project that we started about a decade ago. Inside the company was called Project Digits, Deep Learning GPU Intelligence Training System. Digits.
Deep Learning.
Well,
what?
Before we launched it, I shrunk it to DGX, and to harmonize it with RTX, AGX, OVX, and all of the other X's that we have in the company. And it really revolutionized, DGX1 really revolutionized, where's DGX1? DGX1 revolutionized artificial intelligence. The reason why we built it was because we wanted to make it possible for researchers and startups to have an out-of-the-box AI supercomputer. Imagine the way supercomputers were built in the past. You really have to build your own facility, and you have to go build your own infrastructure and really engineer it into existence. And so we created a supercomputer for AI development for researchers and startups that comes literally one out of the box. I delivered the first one to a startup company in 2016 called OpenAI, and Elon was there, and Ilya Sutskever was there, and many of NVIDIA engineers were there, and we celebrated the arrival of DGX1, and obviously it revolutionized artificial intelligence and computing. But now artificial intelligence is everywhere. It's not just in researchers and startup labs. You know, we want artificial intelligence, as I mentioned in the beginning of our talk. This is now the new way of doing computing. This is the new way of doing software. Every software engineer, every creative artist, everybody who uses computers today as a tool will need an AI supercomputer. And so I just wish that DGX1 was smaller. And you know, you know, imagine, ladies and gentlemen, our
Jesus Christ.
This is NVIDIA's latest AI supercomputer. And it's finally called Project Digits right now. And if you have a good name for it, reach out to us. Here's the amazing thing. This is an AI supercomputer. It runs the entire NVIDIA AI stack. All of NVIDIA software runs on this. DGX Cloud runs on this. This sits, well, somewhere, and it's wireless or, you know, connected to your computer. It's even a workstation if you like it to be. And you could access it, you could reach it like a cloud supercomputer, and NVIDIA's AI works on it. And it's based on a super secret chip that we've been working on called GB110, the smallest Grace Blackwell that we make. And I have,
GP.
well, you know what? Let's show everybody inside.
One petaflop, 20 ARM cores. Holy fuck.
It's just so cute. And this is the chip that's inside. It is in production. This top secret chip we did in collaboration. The CPU, the Gray CPU, is built for NVIDIA in collaboration with MediaTek. They're the world's leading SoC company, and they worked with us to build this CPU SoC, and connect it with chip-to-chip NVLink to the Blackwell GPU. And this little thing here is in full production. We're expecting this computer to be available around May timeframe. And so it's coming at you. It's just incredible what we could do. And it's just, I think you really...
Could say something in his jacket.
I was trying to figure out, do I need more hands or more pockets? All right, so imagine this is what it looks like. You know, who doesn't want one of those? And if you use PC, Mac, you know, anything, because you know, it's a cloud platform. It's a cloud computing platform that sits on your desk. You could also use it as a Linux workstation if you like.
That's bonkers.
If you would like to have double digits, this is what it looks like. You know? And you connect it together with ConnectX, and it has nickel, GPU Direct, all of that out of the box. It's like a supercomputer. Our entire supercomputing stack is available. And so, NVIDIA Project Digits. Okay. Well, let me tell you what I told you. I told you that we are in production with 3 new Blackwells. Not only is the Grace Blackwell supercomputers, NVLink 72s, in production all over the world, we now have 3 new Blackwell systems in production. One amazing AI foundational world foundation model, the world's first physical AI foundation model. It's open, available to activate the world's industries of robotics and such. And 3 robotics. 3 robots. We're working on agentic AI, humanoid robots, and self-driving cars. It's been an incredible year. I want to thank all of you for your partnership. Thank all of you for coming. I made you a short video to reflect on last year and look forward to the next year. Play, please.
Wow. That oh my god, like the idea of AI being able to literally not only just base AI and create and be on the usual AI stuff, but for AI now to be able to make the leap to taking a single or multiple instances of something and literally take that and simulate that into hundreds or thousands of other simulations and figure out the best possible one is insane. It's going to invalidate human, like, situational things at an existential pace, because we don't have the capability, so AI will be able to take what they're showing right now, right? Like, let's say you're working on a car, and this is your list of problems. The AI can go, bam, here's the issue, simulate, 1,000 different things, all in a blink of an eye, and these are your likely fixes, etc. And the AI can literally go ahead and fix it yourself, because it's already been trained by another humanoid. That's not even including things like shipping or like a warehouse full of items, and it analyzing everything that's going on and being able to know the fastest routes to things, the fastest way to gather things, the predicted algorithm of what people might be ordering. Like, basically, the computers will know what to do before we even do. That's crazy. It's dangerous, but I mean, that's what we're getting into.
CES, everybody! Happy New Year! Thank you.
That is that was insane. Likely just took the biggest step toward robotics. Gonna be interesting for you, that's for sure. Like, God, there's just so many, like, good and bad things that I can think of dealing with how that could work. And not only that, but, like, not only are we taking vehicle AI analyzations and simulating all that, but now we're going to be able to do it with the physical world of human interaction more. And then the AI can take that and literally train itself, basically, off of simulated environments and 500,000 different things and methods. Wow. It's going to be insane. I mean, it's literally just getting started when it comes to this type of stuff, but, like, God, the danger is there and the craziness is there. Availability and pricing, etc., probably still not there yet for, like, lots of years yet, because we're just at the cusp of it. But oh man, the things that it can do are gonna be bonkers. And unfortunately, like, we're gonna need regulation. We're gonna need a lot dealing with AI in legal things. A lot. And not only that, but, like, that technology can be applied to video games overall too, and literally take what the computer's seeing us play, etc., what we like doing, what we regularly do when it comes to video games, etc., and literally generate, like, a dungeon or a section of a game or world, or maybe even a game type based around that, off of different simulated environments, and have 100,000 different environments that it could literally pick from. You don't like this one? Okay, well, here's 1,000 more that I've already generated. Like, right there, on hand. Oh, man, there's... God, there's so much there. There is so much there. That's gonna be crazy. Their stock rose right before the reveal, so obviously word was starting to get out more. And the GPUs themselves are bonkers. I'm gonna have to end up getting one. Mine has definitely hit its age now, where I can't really like showcase much of it when it comes to games and such. Yep, the 5080 is twice as fast as the 4080. The 5090 twice as fast as the 4090. It'll have DLSS 4. It'll have Reflex 2, right? I think it's Reflex 2. There's some of the examples of some of the card manufacturers. Oh yeah, laptops too. Laptops are going to be insanely powerful. Yep, DLSS 4. I haven't even looked in the DLSS 4 yet. They didn't really talk about that, which is actually interesting. I expected them to kind of talk about. How long is this video? Let me see. 6 minutes? Let's watch it.
AI is changing everything about how we work and play. And computer graphics is no exception. We've been reinventing computer graphics with artificial intelligence since the launch of RTX in 2018. DLSS is always learning. To improve the AI powering DLSS, we analyze image quality and fine-tune our training datasets and algorithms. Then we retrain the model to make it smarter, faster, and easier to integrate. DLSS is the best way to play. Today, we are introducing the biggest advancements to DLSS since 2020, including new multi-frame generation for RTX 50 series GPUs, enhanced frame generation for RTX 40 and 50 series users with faster performance and lower memory usage, and a new model powering ray reconstruction, super resolution, and deep learning anti-aliasing that enhances image quality and stability for all GeForce RTX users.
Wait, what'd that just say?
Alongside the ability for all GeForce
generating multiple. Oh, that's what he was talking. Oh, that's what he was talking about. Okay. So that's going to be insane. So not only will the AI be able to, that's what I was talking about actually. The AI won't just be able to be predicting like what's next. It can actually predict multiple frames of what's next. That's what this DLSS 4 will bring.
RTX users. Alongside the RTX 40 series in 2022, we launched frame generation, where an AI network used an optical flow field along with motion vectors from game geometry to generate a single frame between every pair
now
of traditionally rendered frames.
Multiple of them.
The Blackwell architecture is built for neural rendering, and that unlocks new AI capabilities for DLSS. We can now generate multiple frames per traditionally rendered frame. To make this possible, our research team developed a new AI model that generates the optical flow field more efficiently and more accurately in order to generate multiple frames. Multi-frame generation requires consistent and precise frame pacing. DLSS 3 frame pacing had variability because of how different game engines divided workloads between the CPU and GPU. With the Blackwell architecture, the display engine was improved to leverage flip metering when generating multiple frames, ensuring that the GPU delivers consistent and optimal frame pacing. Additionally, 5th generation tensor cores on RTX 50 series GPUs have the computational horsepower necessary to quickly execute this series of AI models. These software and hardware innovations enable DLSS 4 on RTX 50 series GPUs to generate up to 3 additional frames between traditionally rendered frames. This brings revolutionary performance versus traditional native rendering. Most frame generation games available today can easily be updated to enable multi-frame generation with the NVIDIA app. In the NVIDIA app driver settings menu, open the DLSS override and select your desired output mode in the frame generation drop-down menu. When RTX 50 series graphics cards hit store shelves, multi-frame generation will be supported in more than 75 games and apps. In addition to multi-frame generation, our team has also been hard at work developing foundational improvements for our existing DLSS technologies.
Today, we're introducing an enhanced single-frame generation model for RTX 40 and 50 series GPUs, which, like the multi-frame generation technique for Blackwell, uses two AI models, one for optical flow and another for frame generation. The result is increased performance and lower VRAM usage, as you can see here. DLSS 4 also introduces a more powerful transformer-based model for super-resolution ray reconstruction and DLAA, using 4x more tensor core processing power to reconstruct images at even better image quality for all RTX owners. Previously, all these technologies used a convolutional neural network model, also known as CNN. CNNs were the dominant architecture for image-related applications during the early years of deep learning development. A CNN processes pixel information through local operations, spatially around a small number of neighboring pixels, and temporally across multiple frames. Now we're introducing a new transformer-based architecture for the first time. The transformer architecture is driving the scaling laws of artificial intelligence, and it's what powers the recent advancement in AI applications. Compared to the CNN models, transformers use self-attention and can much more easily identify the longer range patterns across a much larger pixel window. Transformers scale much more effectively than CNNs, so our transformer models ingest over 2 times more parameters and requires 4 times more compute during inference. In fact, DLSS 4 on RTX GPUs is the first time transformer models generate sequential images at a high real-time frame rate. Blackwell's tensor cores provides additional hardware acceleration that boosts the inference speed of these transformer models even further. When using DLSS super resolution, the end product of the transformer model is more temporally stable, with more image detail in motion. In intensive ray trace content, the transformer model for ray reconstruction gets an even bigger uplift in general quality, especially for scenes with challenging lighting.
That'll actually
all the
eliminate
common
the
artifacts
ghosting
of typical denoisers are significantly reduced. With the NVIDIA app, GeForce RTX users can optionally update their DLSS games with the transformer model of ray reconstruction, super resolution, or DLAA. In addition to games, DLSS 4 is coming to multiple creative apps, including Unreal Engine 5, D5 Render, and Chaos Vantage. DLSS significantly enhances the real-time viewport experience, multiplying the frame rate in D5 Render, enabling designers to better iterate and collaborate on their work.
That's crazy.
Neo rendering is creating increasingly more on-screen content, and these generated pixels are higher quality than what's output by traditional native rendering. With super resolution or ray reconstruction alone, 3 out of every 4 pixels are generated with AI. When adding frame generation, 7 out of 8 pixels are generated by AI. Finally, with the DLSS 4 multi-frame generation, 15 out of every 16 pixels are generated by AI.
That's pretty fucking crazy.
With the RTX 50 series and DLSS 4, we've introduced a new generation of neural graphics, so games are more beautiful, run faster, and are more responsive. The AI-powered future is here, and DLSS 4 is the best way to play.
It's gonna be the only way to play because all the fucking developers are utilizing it. You need to have it. God, that's crazy. I think, if I remember right, let me see here. Final Fantasy 14. Yeah. Yeah, it's looking for an RTX card. God, dude, that's gonna be... Oh, man. I don't even know where to begin. There's so much there. Holy crap. I'm gonna have to end up getting one. My card definitely has been feeling its age. Oh man. I don't even know how, but we're going to have to do it. We are going to have to do it. That's crazy. Oh, this is, wait, which frame warping? Let's see what Reflex 2 is. Besides killing my eardrums.
NVIDIA spent over 5 years studying input lag and responsiveness, which is how quickly a game displays the reaction to a player's inputs. A few milliseconds can be the difference between victory and defeat. Higher latency can hurt performance through missed hit registration, inconsistent aiming, and disadvantages when holding an angle. In 2020, we launched NVIDIA Reflex, which tightly synchronizes the CPU and the GPU to reduce latency by an average of 50% in top competitive titles. Today, we're announcing a breakthrough in our latency research with the introduction of Reflex 2 with Frame Warp. Over 5 years ago, our esports research team published a study illustrating how players aim better and complete tasks faster when rendered frames are updated based on more recent input. For example, when a player aims to the right, it takes some time for that action and the new camera perspective to be displayed. What if instead, an existing frame's camera could be shifted or warped to the right to show the results much sooner?
Huh?
Frame warp reduces your camera latency through this concept, which has gone from research to reality. Let's dive into exactly how frame warp works. As a frame is being rendered by the GPU, the CPU is calculating the camera position of the next frame and
God, it's all centered around generative AI literally going through all the different options all at once. All of it.
in the pipeline, based on the latest mouse input. Frame warp samples the new camera position from the CPU.
So now because they can do multiple frame generation, etc., and they can look ahead in multiple frames, they can, like, warp ahead.
And warps the frame being rendered by the GPU to use this new camera position. The warp is conducted as late as possible, just before the rendered frame is sent to the display, ensuring the most recent mouse input is reflected on screen. In the end, players see the rendered frame, but with an updated camera perspective, reducing latency and improving your ability to aim, track, and hit more shots.
That's gonna be really interesting, because, like, I don't know how that's gonna work with the game itself.
Depending on the frame rate, this process can be happening hundreds of times per second, constantly delivering the freshest camera perspective. Gamers are going to feel truly connected to their mouse movements, whether it's tracking a moving target or quickly flicking to aim at an unexpected foe. To warp to the most recent camera position, frame warp shifts many of the game's pixels, which can create small holes in some regions of the image, especially when mouse movements are intense. However, NVIDIA has developed a latency-optimized predictive rendering algorithm, which uses camera, color, and depth data from prior frames to in-paint these holes accurately. For example, here's the finals with frame warp and no in-painting. And here's what it looks like with in-painting. The result is a frame which shows the freshest camera position.
Oof.
Is a frame which shows the fresh, like with in-painting.
You can see it. God, they're gonna use motion blur even more now to try to cover up the edges of things doing that. Like, you can see it, especially along the actual arm.
The result is a frame which shows the freshest camera position seamlessly inserted into the rendering pipeline. Using this cutting-edge warp process, frame warp reduces latency by around an entire frame time, which amounts to nearly another 50% of latency savings on top of reflex low latency.
This is with the 5070 as well.
Mode, for a total reduction of 75% from native. Players will experience improved target acquisition, faster reaction times, and tighter aim precision. Let's see it in-game. In the finals, without reflex, players can see a moderate amount of PC latency. Turning on reflex low latency mode reduces latency significantly. Activating Reflex Frame Warp reduces input lag by another 50%, for a total reduction of 75%. In the finals,
what did I just see?
Amount of PC latency. For a total reduction of 75% from native, making it easier to track targets in motion, land flick shots, secure eliminations, and the win. And unlike Reflex Low Latency mode, Reflex Frame Warp provides significant latency savings even in CPU bottleneck scenarios. Here, we have Reflex 2 enabled in Valorant, a CPU-limited game that runs blazingly fast. Frame rates are not only insanely fast, but PC latency now reaches below 2 milliseconds. This is the lowest latency figure we've ever seen in an FPS.
Well, yeah.
We're bringing Reflex 2 to top competitive games like Valorant and the finals, with more to be announced in the future. Reflex Frame Warp is coming soon for all GeForce RTX gamers, and will be available first on RTX 50 series GPUs.
That's gonna be insane. Holy moly. Okay. Wait, NVIDIA Ace. Oh, they didn't talk about this either. AI teammates, NPCs. Oh, okay. Hang on. This talks about the AI thing I was talking about when it came to gaming.
At Crafton, we are revolutionizing the Battle Royale genre with generative AI. Introducing PUBG Ally, the world's first co-playable character designed to play like a human teammate.
What?
Hey Ally, I'm looking for a level 3 vest and 5.56 ammo. Keep your eyes peeled.
Found a level 3 vest and ammo nearby. Pinged it for you. Enemy spotted. I'm covering.
Holy.
Is there a vehicle
Dude,
nearby?
are you watching this?
Found one.
No. The NVIDIA AI, what do they call this? The NVIDIA Ace. They're bringing it to PUBG first. And it'll be the first AI-based, like, ally that you literally, like, interact with and tell it what to do and everything else. Yeah, let me see. I'll roll back a little bit.
Hey Ally, I'm looking for a level 3 vest and 5.56 ammo.
Oh, yeah, I know what you're talking about. This one apparently does it, like, on its own, too. Like, tell it you're looking for an ammo, it finds it for you, it pings it for you. It notices an enemy, so it pings them and, like, covers you.
Keep your eyes peeled.
Found a level 3 vest and ammo
Yeah,
nearby.
literally.
Pinged it for you. Enemy spotted. I'm covering.
Is there a vehicle nearby?
Found one. I will come to you.
It picked up a fucking car.
I'm ready to get into the action now. Can you flank them?
On it. Moving left. Wait. I'm not.
Dude, you tell the AI to flank and it flanks.
Out. Crawling to you now.
Just hang on. Whew. I couldn't have done it without you.
I know. I carry for a living.
Oh my. Solo, but like a team. That is fucking bonkers. That's crazy. Like, there's so many good and bad practices to these situations that, like, it's gonna be, I don't even know. I can't, like, I really want to get my hands on one so that I can put it through the ringer. Project R2X, a vision-enabled PC avatar. Holy shit. This also will have the ability to, I mean, we technically already have this type of thing, but read and summarizing documents, cloud AI services to open AI's GPT-4. Oh my god. That's going to be, wow. God, there's a lot there, man. How much is NVIDIA worth right now? I know I told I told people years back that if you were going to invest in a company, I'm terrible with investing, etc., because I can't do it, but to invest in NVIDIA. And if anybody did and they listened, they are going to be fucking rich. I can tell you that much. Yeah, they went up again today. After all of this showcase, it closes at a new record ahead of the keynote. Man, they are probably going to... That's crazy. That is crazy. Well, because of work. Damn, man, that sucks. I mean, like, it's still probably, like, if you can afford them, it's still probably worth getting stock from, because, I mean, they are the forefront of AI as it stands when it comes to medical, when it comes to robotics, when it comes to computer graphics, from computer design to the medical field to, like, everything, right? Like, they're only going to go up at this point. Like, unless, of course, something drastic. They make robots and they kill everybody. Like, I don't want to be, like, that crazy, but, you know, like, Terminator drastic. But, like, even then, it would be tied to the company that didn't train correctly or specs to it, I'm sure, you know, yada, yada, yada. But I will say I am happy that the prices were lower than what they had slated for stores and partners. But more than likely the 2000 that's going to start at for a 5090 is probably going to be jacked way, way up. Not only by the companies that are going to work on the cards, but if you're in the US, we are going to get shit on with tariffs. So it's going to be interesting. It's going to be an interesting few years. Damn. Anyway, I'm going to jump off of here. I'm going to cool off a little bit, maybe grab some food real quick. And I might jump on some PoE. I've been on PoE the last, like, couple days, a little bit here. So my neck is starting to flare up, though, so I'm going to get out of here. Thank you for hanging out. Work and government rules prevent from having over a certain amount of stock in there. Oh. That makes sense. Which is weird because there's so much governmental insider trading, etc. in the Congress. Not in Congress. I like how you clarified that. Yeah, exactly. Damn, man, that's crazy. Well, hopefully you can utilize what you got. I know I would love. But anyway, I am out of here. thank you for hanging out. Hopefully you guys enjoyed that. That was those people that are probably going on and on and on about way more in-depth technology that I have no clue about. So I'm sure there's plenty of people that'll like analyze all that way more than I could. I'm looking at it off the cuff and like my understanding of things, etc. So I definitely need a card. I need a new NVIDIA card though, so it's gonna be I don't know how. But anyway, I'm out of here. Thank you. I will catch you all later. And you guys have a good night. Happy New Year. I'll see you guys next time.